Welcome back, you guys. We're starting on section 2.4, the distributive property, and that's learning target 7, which is using the distributive property and simplifying expressions. I asked you to work on these two problems before you turned on the video, so let's go over it. Hopefully you remember from middle school that area of a rectangle is length times width. So hopefully you were able to get here 21, and if you put feet squared in units, great. If not, I wanted to make sure you knew it was length times width. Over here, length times width would be 6 times x, and it's 6x. Please remember that we're not writing it with the dot in between, and we do want the number first. Okay. So then on these two, I asked you to be creative and think of 2 different ways you could find the area. I have a feeling that some people on here said, okay, length times the width, which we know the side is 5 plus 4. So we have 3 times 5 plus 4, which the length, if I write it like this, length times width. So our area equals 5 plus 4 is 9. So our area is 27. Some of you, maybe that's the only way you thought to do this. Other students, maybe you said, hey, I knew that with that line down the middle, I could have found the area of this piece, which was 15, and this piece, which was 12. And you can say, hey, if I add those together, the area is 3 times 5 plus 3 times 4, 15 plus 12, or 27. We should see that it doesn't matter how we did it, we got the same answer. On this problem, 2 different ways to have done it. Length times width, so area is length times width, which is 3, and the width now, or I guess going up and down, is x plus 2. That's length. Some other people may have done it by parts. The area of this box is 3x, and the area of this is 3x plus, oops, sorry, that's a mistake. Good job to me today. Let's try that again. This area is 2, that side is 2, and this side's 3, so this area is 6, so that would be 3x plus 6. Okay, what this does is it shows us that there's 2 different ways to do this, and hopefully you're able to recognize this as the distributive property. Hopefully here, if we look at the second example, you can see that there's also a 3 times an x and a 3 times a 2 to get the 3x and the 6. Or maybe over here, if we go back to the first example, you're able to say, hey, right over here, you can do 3 times 5 and 3 times 4. To get the 15 for 3 times 5, and the 3 times 4 is 12. Here are the directions, or here are some examples or the rules, and I have that written on your notes page, but here is the distributive property, and they're just showing you different ways, one with a plus sign, one with a minus, and I can take those off just so it doesn't look as sloppy. And then also over here, when the A is after the set of parentheses, and it's just different ways. If you want to pause it and look at that a little more, be my guest. So here's what we have. We have 4 problems. I'll do the first one for you and ask you to pause it, and then you can try the other 3 on your own. So here, distributive property. 2 times 5x and 2 times 3. 2 times 5x is 10x, plus 2 times 3 is 6. Please go ahead and pause this and try the others and see what you get. All right. So if you're back on here, this is what you should have gotten. 6 times 2n and 6 times negative 7. So that should be 12n, and 6 times negative 7 is negative 42. On C, that's one of the ones where the parentheses were after, so we're going to distribute in here and here. 3b times a third, so a third of 3b is just b, and then negative 2 times 3 is negative 2 thirds. If you're having trouble with that, it's negative 2 times 1 third. Don't forget, negative 2 is negative 2 over 1, so you're left with negative 2 over 3. That's just what I wrote over there. And on this last one, it's negative 5 being distributed. So negative 5 times 4w is negative 20w, and negative 5 times negative 9, don't forget that's a positive, 45. Please circle any you got wrong and come in with questions. On here, here's 4 problems, and I would love for you to take the time and just try to write out these in English, or from English into mathematical notation, and then do the distributive property. I'll do the first one for you, and then you can pause and work on the others. So the first one's the product of product, don't forget that means multiplication, of -6, and the quantity of means parentheses 7 minus m. So I'm asking you on the other 3 to write this out and then to also do the distributive property. So here when we do distributive property, you should get -42 and then plus 6m. Pause it and please work on the other 3. Okay, so on here, that should be times. 3 times the quantity x minus 5, 3 times x minus 5, and when you do the distributive property, it should be 3x minus 15. Here it's -2 times t plus 7, and distributive property. And on the last one, the product of 4 and the quantity of 8 plus w, so hopefully you had 32 plus 4w. Please let me know any that you had questions on. Okay. I want to make sure, I know you guys have thought in here, we've talked about it or in other classes, that when you multiply by -1, you're basically changing the sign. This comes up a handful of times in the distributive property, but a lot of students miss it. So in this first example right here, even though it's not written this way, it is -1 times that. So really you're distributing a negative to each of those, or you're multiplying by -1. -2x minus 1. Pause it and try the others and come back.
Attention C team, please.
All right, sorry about that. That was interruptions at the end of the day. We're going to distribute a -1 in here, and here we'll have -3 plus 8a. You're changing the sign of every term inside when you multiply by a negative. Here you'd get -6x and -4, and hopefully here you got -5q plus 6. We're almost done. Next thing I want you to do is to write down these definitions for term, constant, and coefficient, and then come back together. So in here, hopefully you know a term is a number, variable, or a product of a number and a variable, and they're separated by plus or minus signs. Okay, examples could be like 2x plus 4. 2x is a term and 4 is a term. It's a number like 4. The product of a number and 1 or more variables like 2x, those are both terms. A constant is a term that has no variable. So in this example, 4 is the constant. 4 is always worth 4. And the next one is coefficient, is a numerical factor of a term. And as we talk about like 3x, I've used that word in here a lot. It's that 3 right before it. So now that you have those definitions on your paper, I'd love for you to take this expression right here, or this long expression, and write down what each of the terms are, each of the coefficients, and what the constant is. And here is what you should have.
There will be a National Art Honor Society meeting in room 414 at 3 p.m. today.
Okay, sorry about the announcements. Here you go. So on here, what we should have is the term. One of them is 6a squared. Then I see a subtraction sign. A lot of people miss this. It should be 5ab is the next term. 3b, I don't need to write it as positive 3b, is the next term, and 12 is another term. The coefficients are here are 6 and -5 and 3, and the constant is negative. Okay, sorry about, I keep getting disruptions. Okay, so here you go. Really quick, I just want you to look at here and see what like terms are and non-like terms. Like terms would be here like 3x and -2x because they both have an x. Like terms here are x squareds and x squareds. They look the same, xy's and xy's. Don't worry about the numbers or the coefficients in front. Those are okay to be different. Here I have an x squared y and an x squared y. So on the left side here, those are all like terms. Over here, x and y are different. You can't add those. You can't add a y and a y squared. Or here a y and an xy. Here an x squared y or an xy squared. They're all different. So what you need to know is you can only add like terms. So to finish off your notes, I would love for you to work on these examples, and we'll go over them when you come back in class. And that's where you're going to just be combining these like terms. I'll do the first one for you. If I have 3x squareds and 5x squareds, to add them together, you get 8x squareds. Okay, it's how many of those do you have? So go ahead and finish this, and we'll talk about it tomorrow.